Slack channel. I'd like to invite our next speaker to start sharing their slides while I introduce them. Our next speaker is Ashkbiz Danehkar from the University of Michigan. He's going to talk to us about Bayesian X-ray spectral analysis of the symbiotic star RT crew. Go ahead, Ashkbiz.
Thank you for introductions. And today I will talk about my recent study of the X-ray spectral analysis of Symbiotics star RT crew, which done using Bayesian MCMC studies. I did this work in collaboration with Margarita and Jeremy and Bina at Center for Astrophysics. Symbiotics star are a binary star which consists of hard accretion core, such as white dwarf, and cool red giants. And typically they have a soft or super soft X-ray emission. However, a few of them, they show hard X-ray emissions, such as RT crew. The origin of this hard X-ray emission, not well understood. This hard X-ray emission has energy higher than 50 keV, and it has been suggested that probably related to massive white dwarf close to Chandra's hard limit. So they could be a progenitor for type 1a supernova. RT crew has it has a very high X-ray variability. And for a study of this RT crew, we use Chandra high energy transmission skeletons, which collected in 2005. And we use also low energy transmitting skeletons, which collected in 2015. And we separated low and high states using these hardness ratio diagrams. And by separating these events, we made to different spectrum in lowest state and highest state. Also, we made time average spectrums. And we did it a Bayesian low count X-ray spectrum analysis using PyBlocks CXS. And by fitting Makel and Apex, we found two components, one of them hard X-ray component at 10 keV, which previously found in 2007. And we additionally find a soft X-ray components at energy 1.3 in the time average spectrum, which is something new, and it is heavily obscured by high column density dense materials. And in order to do this fitting, we use Chow statistics, and we simultaneously fit background and source. And by simultaneously fitting background and source and using MCMC base, we produce posterior probability distributions of best fitting parameters. And as you see here, we find 1.3 keV for the soft components, but it was heavily absorbed by column density of 75 times 10 to the power of 22. But for hard thermal component, which is around 10 keV, it has low column densities. And we did similar works. Thank you for this similar works for low or hard spectrums, and we find different components in soft and hard thermal emissions. And also we did it for high or soft spectrums, and we also find different components in high states. And here is a summary of the result for soft thermal component. As you see, it was heavily obscured by column density of 75 times 10 to the power of 22, and this was heavily obscured. But the hard X-ray component was around 10 times 10 to the power of 22, the column density, so it's not heavily obscured. So these hard and soft thermal components have been found in other hard X-ray emissions and symbiotics like CH6, 0.2 and 0.7 and 73, and also NWC 56, and also WS73 and 17. So this is the soft and hard components. It has been found in different hard X-ray emitting. And it was suggested it was related to shock wind or unseen jets, which we didn't find in currently there is no imaging observation article, so we are not able to detect unseen jets. And in summary is this article has large X-ray variability, and for this study we separated hard and high states. And in time average, we found two different components, which 10 kV, which previously found. And we additionally find one 0.3 keV, which heavily obscured by dense materials. And it needs further study to find the origin of these soft components. And this result is published in Monthly Notice for the Astronomy Society. And here you see, you can look at the archives, preprint of it. Thank you for your attention.
Thank you, Ash, for that very enlightening talk and very interesting work. Really pushing that data to its limits and to learning quite a bit from it at the same time. We don't have time for questions. That was a good 5-minute talk on RT Crew. If you have any questions for Ash, do put them into the Slack channel. I want to